my name is Ming Liu. I'm working for the Navy. As I mentioned before, I have a Navy project. It's about the effect of climate change on design of the piers and wharf. And last September, we had a workshop at the U.S. Navy Academy on the resilience of the Navy waterfront facility in a changing climate. The part one was focused on the extreme wind speed and sea level rise and the flood load. I believe Jennifer was there and Don Scott also was there and many people was there. So next slide, please. So the purpose of the workshop and my project is to improve Chapter 3, load requirement, and Chapter 4, structure design of the UFC code for piers and the wharf. UFC represents the Unified Facility Criteria. It's a design code used by the DoD. It's similar to the IBC, International Building Code for the buildings. So we are also developing a new ASCE design code for piers and wharf. Dr. Omar Jerka, he's here. He's the chair of the committee. There are so many load and load combination we have to consider in design the piers and wharf. So my project cannot cover all. So now we focus on the 3 non-stationary of extreme design load of wind speed, flood velocity, and the sea level rise. Next slide, please. This slide, I show the design load, including the UFC code for design of piers and wharf. Section 3-2 is talk about dead load, and 3-3 is vertical live load, including uniform load, truck load, crane load, forklift load, load on the railroad track, buoyancy load, wave load. You can see this load is not really related to the climate change, not climate sensitive parameters. Next slide, please. However, when you look at the horizontal load, the person load, and the mooring load, wind load on the structure, and the load on the piles, including the current load and wave load, this is much related to the climate changes. It's climate sensitive parameters. That's what we need to consider doing the design of piers or wharf. And next slide, please. Before we jump to the question we're discussing for the workshop, I want to report to you the registration status on my workshop. There were 77 people registered, about 70 people showed up. Half of them from DoD side, 12 people from NAFA, 12 people from US Naval Academy or local people, and 11 from the US Army Corps of Engineers and the Air Force. We had 15 industrial people from consulting, and the rest of 20 is university professors, academic. Next slide, please. Before the workshop, we did a survey, say what we want to talk about during the workshop, what is interesting, and the 4 topics: wind, flood, sea level rise, and the resilience. Next slide, please. So this summary of what we find out. Only 1/4 of the people interested in the wind, and 40 people interested in the flood, and 2/3 of people are interested in sea level rise. 3/4 people all interested in resilience. It's kind of surprised me. There's only few people interested in the wind and the coastal area. I figure out, I'm guessing probably most of the participants, many people don't understand how to develop the wind load for the structural design. It's complex, so they just take a number from the design code. Most of people are interested in the flood damage and the consequence of and the sea level rise, and then how to deal with those through the resilience planning process. This is why the part 2 of my workshop will be held in coming April. I think April 23rd and 24th. 2024 at the ASCE headquarters, Reston, Virginia. This is the theme of the part 2 is resilience planning life cycle cost engineering, and adaptation engineering. So this is an invitation-only workshop. If you are interested, please send an email, let me know. I will send you the invitation letters. That's today, April 23rd and 24th in Virginia, ASC headquarters. Next slide, please. Okay, let's jump to what we have discussion in the workshop. There were 18 questions. 6 is general questions about methodology, 6 questions related to wind, 3 related to flood, and 3 related to sea level rise. The first general question is about the return period. You know, we're dealing with non-stationary climate scenario. There's return period may not applicable for our case. I believe your report, your technical memo published last July also talk about this issues. So you have a 1-page column, I see that. We want to consistent with whatever you come from ASC7, the future climate consideration. It looks like we're not going to use the return period, but we still mention those. And, the second question is about the risk category. ASC7 focuses on the buildings and the public safety. This is not always the case for pier and wharf design, because public safety is only important for the ferry terminals, the public passengers go there. Most of the piers and wharf, there's not many public show up in the piers, but we more focus on the functionality, see how make sure the operation, the pier operation, the port operation, and reduce the downtime. And also the environmental issue. There's many examples, the oil speed into water pollution, the big issue. If that causes the pier and wharf failure, that's the big issue. And we also consider some total owner cost. And the ASC committee on the piers and wharf, there's many members, also is a member of ASC 61, seismic analysis of piers and wharf. And the ASC 61 uses the risk category of high, medium, low is different. So there's some discussion. I think the conclusion will follow ASC 7, risk category 1, 2, 3, 4, but we have a different definition how to categorize based on different factors, and go with ASC 7, whatever you have. Next slide, please. The next question is about the uniform hazard design and the uniform risk design. Because ASC 61 seismic design currently use the old uniform hazard design based on the ASC 7 2005. Now we switch to the uniform risk design. So now what are we going to do for the pier and the wharf design without seismic? Because ASC 61, their approach uniform hazard design. So looks like we're still going to use the uniform hazard design for the new ASC design code for pier. But I try to push the uniform risk to be consistent with ASC right now. I will see what happened. Next question is keep that one, please. Sorry. Next question is related to uncertainty resource. This is a figure is from your technical memo. I like that. They tell you the source of uncertainty. Your uncertainty of data, uncertainty of model, or scenario pickup. You can see from here, 30 years about its scenario selection will dominate your uncertainty. So this comes to the question, the next question is the time frame. Next slide, please, Megan. Yeah. And what time frame we should design for? There's 25 years already in the UFC requirement, and buildings is design life is 50 years, bridges 75 years. The conclusion, I think, we're going to use the surface life is 25 years to 30 years, and design life with 50 years or 75 years, similar to the bridge, because piers look like a bridge. By the way, I want to mention DoD right now currently focus on the climate prediction about next 10 years for the short term, because we understand uncertainty about the scenario pickup. So for DoD installation, it's kind of relatively short time period we're looking at. 10 years or 15 years is the focus right now. So next one is about scenario pickup. So looks like we're going to use the sea surface temperature as the standard, be consistent with ASCE 7, what we are doing here. Final question related general is the balance between the current design code and the resilience planning. Structural design code is focused on the structural safety and the lifecycle cost and on the component level. Resilience planning is on the community level, focused on the rapid functional recovery. That's two kind of different things. So we have a little bit of discussion, see what we're going to do for these two different things. Next slide, please. Okay, now we move to the wind discussion. There are 6 questions. The first one is for the future wind prediction. Are we relying on the modeling, or what's the role of the historic data, observation data? Looks like we are most use the observation data to validate the numerical models, and the future predictions still relied on the model, because long stationary means historic data is no longer good enough to predict the future. And there's many AI machine learning people doing this kind of things. It's very interesting to see what come out next. So another thing is tropical storm got been included Piers. Our understanding for ASCE is wind map is primarily focused on the inland structure. The wind speed, the wind categories for the Piers, which is over the water, kind of different than the inland buildings. That's our discussion, what are we going to do? And also the SST increased to 1 degree. Some studies say 15 to 30 mile per hour wind increase. Is that true or not true? It's turned out probably it's just one individual study, not quite true, because uncertainty in current wind map, and also uncertainty, there's different opinion. I think Peter Victory, he developed ASCE wind map. His opinion is uncertainty existing wind map already large enough. So what climate change is really questionable. Okay, next slide, please. So next one is because we are facing the water from a structure is water. So we are using expose D, any simplified way method to just get one number. Answer is yes, we're going to do that. The 2 more wind questions about the mooring load. This is a very new for the structural people here, but never heard about. The mooring load is when the ship parked next to a pier, there's a cable connect to them. So when the wind, the ship moving, they generate the load. So it's highly correlated with wind and mooring load. Mooring load only apply to the tension, pull out the pile or the structure. And there's a personal impact to the horizontal, the structure. And also the cable, the direction, because when sea level rise, the angle of the mooring cable does make a difference. So this kind of very special issues for the design of Piers wall, never been considered by AASHTO for bridges or building for ASCE 7. Next slide, please. So this slide shows you a little bit what the mooring the load look like, just for your information, very brief. They actually have 4 kind of mooring service type. Type 1 called a mild weather, which means when the wind load is wind speed more than 40 miles per hour, the ship got to leave the pier. There's no longer have the connection, they got to leave. And the standard mooring is designed for 74 miles per hour, the wind, they must leave. They also has a type 3 heavy weather, which means during the hurricane, the ship still has dock on the piers because the ships in the repair, there's no engine, they cannot move. or other things they cannot will have to there. And the fourth one is a permanent. Some piers convert to the restaurant, the museum, and this will be there forever. There's some different requirement for the wind speed. Right now, we are trying to establish the wind model for different type of the mooring service. The mooring node also is the tide or all kind of affect those things. It's kind of complex. That's one issue we're facing for Piers Wharf, very special for this design call. Two more things I want to mention the wind is for the pier, the mooring design, we use the 30-second wind speed, not 3-second wind gusts. So when you convert the map, the number from ASC7 map, there's a factor 0.51, 0.57, 13 to 15 reduction the number. Second is more important is wind gust front. This is unique. Next slide, please. When the typhoon comes, did you see the top is the wind velocity vertical and the horizontal is time. The wind speed can change, can double from 40 miles per second, 20 miles, whatever the number comes in 1 minute, most of 2 minutes. At the same time, the direction of wind will change, minimum 30 degrees or 40 degrees, like a hurricane, right, applied to the mooring. This and the short moment create a large mooring cord and break the mooring cable or other damage is being happen. So this is very special. So how we're going to deal with those mooring node, that's special things we need to talk about. Next slide, please. Okay, two more slides. And this is a flood. 3 questions. First is talk about how we deal with non-stationary flood. ASC 728 route provide a scaling factor. That's big table there, but that's not for non-stationary anyway. So there's a local effect. They have table, but coastal flooding people they generate a different model to predict local effect and the non-stationary. And the famous one is NOVA has a model as far as FEMA, also USGS. And the people, I went to the workshop from UCSD, University of California, San Diego. There's a Scripps Institute of Oceanography, there's coast. And Oregon State University, not Hawaii, they have their own model. Which one we got to use? So my opinion is we should follow the ASC7 for general framework. For the local effect, maybe I can allow them use the particular model for the port, the harbor, and there's whatever we can. That's what will be in the future discussion. Compound flooding causes a lot of damage is the focus one. And we are focused on the pile support design for structure purpose because most of pier are supported by pile, steel pile, and the precast concrete pile. The final is about the extreme water level. This is a very important design parameter for the dry dock because uplift, even the piers uplift for extreme water level. There's a lot of study, as I know, the NOVA and the FEMA DOD. Also, I heard I went to the different shop. There's different university has their model. One thing is a hurricane path plays a critical role. If we prediction on the assumption of the hurricane path, they will be very high. If the location there's no hurricane path, that's very low. Even the historical data, some kind of issue here. Okay, now last slide, please. It's about sea level rise. Sea level rise discussion for us is focused on tools. We know NOVA has a model. DOD has the regional sea level, DISL model. Question is which one got to use? And this answer is very simple. DOD installation must use the DOD tool. And the city around it, local government use the ASC NOVA tool. They're slightly different. You see there's an example, but we don't think there's will cause the major problem issue because difference are very small. Another thing is DOD allowed 2 approach to deal with sea level rise, which one we're going to use. And when you got designed the the seawall, the high, you have to combine the sea level rise and the storm flood. So current U.S. Navy Academy uses 75 years sea level rise plus 50 years return period. Can we add it up? And the decline say, yes, we can do that. So as long as you pick up the number you are comfortable with, you can do that. So next slide, please. This just show the last slide and the two approach about sea level rise currently approved by the UFC, by the DoD. Everybody in the DoD has to use those. The first one just depends on ASC flood design class 1, 2, 3, 4. You either add 0, 2 feet, or 3 feet. Very simple. You just say how important your facility, add it 3 feet the most conservative. Another one is DRSL. You put your location, they will show you the table like this. So you based on the sea level at 2065, lowest, low, medium, and high risk. So you just go pick up the number for your planning purpose. That's two approach. Now we have to decide which one we're going to use and do we allow both of them. I think that's all about what we discussion in the workshop. So next one, we're still working on the Pier and Wharf design. Last week, we just have a committee meeting and talk about some issue over there, and it's ongoing. I think the next 6 to 9 months, we try to get this squared up, and I will report to you what we final the result for the load compilation, load factors using in the design of Pier and the Wharves. Okay, any questions? Thank you.
All right, questions for Ming? Omar, do you have anything you want to add?
Just want to maybe kind of summarize some of the points we discussed last week in our committee meeting related to this. Very quick 4 points. We are looking at using performance-based design for the new standards for ASC standards for Piers and Wharves. Looking at, like Ming mentioned, risk categories definitions. We're going to adhere to AC7 risk categories, but we're going to modify them to make them clear this is for marine structures. So just adjust them to meet our needs. And then we are big focus on efforts to work on load factors for specific for work on a marine environment, control terminal access for live loads, load factors for wind load, mooring and berthing, wave and current. There is a lot of need for research and specifically collecting data to support our efforts. And Ming is taking the lead on this one to lead a team of experts to help us come up with load factors. We have other committee members already collecting data and coming with load factors for this effort. And then we are going to use ASE, NOAA, FEMA, USGS data tools. We'd like to understand how the data tools from these entities can be used for marine structures or marine environment where close to the coast and stuff like that, if the data needs to be modified or accurate, or some of the data in ASC is mainly for land-based, and we need to, we do a lot of coastal evaluation to calculate coastal modeling to calculate loads and wave loads on the marine structures. And we would like to continue our ASC, COPRI, and ASC SEI coordination closely so we can exchange information about our specific needs for the marine structures, marine environment. Thank you.
All right, thank you, Omar. Questions for Ming or Omar? I'm sure there are a few. Well, I guess I'll get things rolling. Obviously, there's a heavy emphasis on wind loads in your presentation, Ming, and I can imagine that plays a role in many different ways. Some of the discussions that I've been privy to with different groups that are involved in climate modeling and as we explore the use of climate projections to help us understand future conditions, wind comes up quite frequently. And there's been a bit of a discussion about whether or not there's sufficient attribution studies to support the use of climate projections for wind loads. Whether or not there's enough skill to use projections for wind loads. I know, Dan, Barry, you've talked about this before in some different venues. Allison, I know that was something that NASA was looking at. Is that a subject that needs to be discussed? I know we're having a workshop tomorrow afternoon for the wind loads task group of ASCE 7 chapter 36, which is Sihan Lee is one of the co-chairs for that. And obviously Don and Jennifer are on a call, but it seems to me like there's a lot of intersection of interest here between these standards with respect to wind loads. And I'm just wondering whether or not, some kind of a broader conversation involving these different ASCE committees would be useful.
Yes,
anybody want to go ahead? I don't know who that was.
Yes, thank you, Dan. Yeah, so yeah, that's the things, as Omar mentioned, we are dealing with waterfront. The waterfront, the tropical storm is decreased rapidly in the land, but it's not for our case. So I was looking around, I asked around for the NOAA people, other people, wind people, say what we're going to do. We do need to have weather station close to the Piers and Wharves, some data. But so for our group, I don't think we have to process those data. So we do need help from NOAA or other people. But we understand it's not the focus of what you're doing, because SE focus on inland buildings. There's a lot of other things to compilation to do that. So for our case, it's relatively small effort for you, I believe, but we do need the experts on this one to see what's the rational model we should use for our Piers and Wharves design. Another thing is the wind on the structure itself on the pier and Wharves is not that big, because we don't have much surface area to capture the wind load. It's just like a bridge, and that's the things. But the mooring node, that's kind of different because ship has those things there. Yeah, so we do need help from you guys, your group, and we are going to follow your group, and we are going to use the wind map in the ASCE 7, no matter what. Like, we probably added some modification factors to be consistent with whatever this group doing. Omar, you have any comment, addition for this?
Yeah, I think I understand the question. Shall we collaborate between all these different efforts? Definitely, if there is any way we can, marine environment, marine structures has special needs sometimes for the loads, how it's looked at and collected the data and how it's implemented. We would like to coordinate that. ASC committee right now, and COPRI is not in the business of collecting data. It's a massive effort. We don't want to repeat any of that. If there's any way we can provide our input to the data collected, will be tremendous for us. Thank you.
All right, thanks, Omar. I've got Joe and then Ben.
Hi. Yeah, I'm unmuted now. Thank you, Big. That was a really excellent presentation. I'm wondering if those questions and answers and the results from that workshop have been written up, or otherwise, if you could share that presentation, because I'm very, interested in how these sort of overarching questions play out in this process, and how climate data can be, analyzed and presented in such a way that it supports this effort. And I thought those questions were very excellent. Many of the same ones came up in our workshops a year and a half ago as well. So I don't know if that's the first question. Is this available? Is that sort of Q&A at least available?
Yeah, I'm still working on those one. The result will be presented in the part 2 workshop in April 23rd and 24th. The first step is report whatever we come from those questions. That's about 30 or 40 minutes. Yeah, so I'm still working on not finalized. I have a research team, review panel, and got to review those things, make sure we're heading in the right direction right now. Yeah.
And the second sort of substantive question I had was about the risk categories. And one thing I'm noticing as these come up is that when you're dealing with the sea level question, I know some people are interested in having the higher risk categories map onto a higher sea level rise scenario. And at some level, that's not quite consistent with the idea of a 3 degrees Celsius global temperature, because obviously the higher sea level rise scenarios, particularly the very high ones, are consistent with different levels of global warming. So I don't know how we're all going to go through that. There's probably many ways to square that circle, but
yes, you're right. There's inconsistent with that. The DOD, like the risk category 1, 2, 3, 4, at the 2 feet or 3 feet. The SST is another. We talk about window. Yeah, we still try to figure out this. That's one way we need to follow the current DOD the guidelines. Another way for ASCE, we might be go to the SST that approach. Again, we need to do some sensitivity study, see how the difference will be generated, and see what a typical calibration things result. It's a huge difference. We have to do something. Otherwise, we probably follow. Bottom line is follow ASC 7, whatever you have the sea level rise there.
Yeah, I can add quickly to this one is the marine structures we're dealing with is mainly for no public access. We're trying to establish minimum standards for everybody, but the one with no public access and they have high importance for the economy or the defense, they will have at the higher standards. They will combine everything on top of everything, so they're not shut down. They are not impacted their operation for 50 years, the life of the structure. So you will see the extreme on both ends for our standards.
All right, thank you, Omar. I'm very conscious of the time here. We're way over, but Ben, I saw you had your hand up. Are you?
Yeah, maybe you could go on, because I think my things have already been addressed. I mean, I had the one reaction I had. I mean, first of all, thank you. This is really, really good information, very rich. It just struck me as I was listening to the presentation. It just, to me, underscored the need for us to try to be as consistent as possible in the use of our climate scenario information modeling assumptions across all these parameters: sea level rise, precipitation, temperature, so that we're staying on an apples to apples basis as much as possible. And the second thing was the 3 degrees warming that broader ASCE has adopted, to what extent that factored in. But I feel like to a large extent it's already been addressed. So
all right, thanks, Ben. And I assume Jamie, you and somebody else had their hand up. I think you pulled them down. I guess just real quickly, to me, the question is, how do we support this effort? And what I'm hearing is largely if we support ASCE 7, that will in turn inform this process. But that's a pretty big assumption. And so Ming and Omar, I'd kind of like to explore that a little bit more to understand where your needs might differ slightly from ASCE 7, and to what degree NOAA and our federal partners can help meet that need if there's a specialized need. I guess my general reaction is the more interaction you have between the two committees and the more we're aware of that interaction, we can help. But what we don't want to do is find ourselves in a situation where we're going to NOAA and every standard has a different shopping list of data sets, because we can't. That's the whole purpose of working with ASCE, is that we're trying not to ask the federal agencies to create what I refer to as a bespoke climate projection that's really unique to one little application. The more we can coordinate, the better. But Jennifer, real quick.
Yeah, that would be our goal too, Dan. So I think part of the follow-up, and Ming would agree with that, part of the follow-up of the first workshop was to connect the standard development effort that Omar is leading with some of the 7 folks who've been working on these hazards to really understand the need for these documents and if and how they might differ so we could work on that together. So that was for sure one of our action items when we left that meeting.